As we start section 6.4 day one, you should be in a very comfortable place with what you see in the PDF notes. This is the end of, I guess, the unit circle and the end of high school version of solving a trigonometric equation. Why would you feel very comfortable? Because you've been doing this for quite a while. As early as pre-calc 20, we began solving this. The first time we ever did the unit circle, we solved for values like, what is the exact value of the sine of 30 degrees? And then we would find the value. And then the very next day in pre-calc 20, we were given something like this, where we took the answer and said what angles would solve this equation. And so in number one in the PDF notes basically just says that. Solving a trigonometric equation is saying what values, what angles would make this work, where what values could we put in for x, and we will get answers of negative root 3 over 2, either exact with the unit circle or the decimal version with the calculator. So what we did was we always had our unit circle in front of us, and once we were at this spot, I called it your happy place, because there's nothing to do. Sine is y over r is always 1, and then we would look at the unit circle, where is the y value, negative root 3 over 2, and in number 2, we were working in degrees. That's the stipulation that's in the PDF notes. So we found that at 240 and 300, it was negative root 3 over 2. And in pre-calc 20, we realized, yeah, we can't use 120 or 60 as answers because they're positive root 3 over 2. Then we step up to pre-calc 30. In pre-calculus 30, especially chapter 4 that we just finished, then we started to up our game. And that whole little phrase of get to your happy place starts to make sense. We would take an expression like 2 cosine x plus 1 equals 0. We would have to manipulate it, and it's not hard. We subtract the 1 over, divide by 2. Now you're in your happy place. Now it's just like pre-calc 20, where it's the unit circle. I call it backwards. We're trying to find the angle. Cosine is x over r is always 1. And then we just simply find, well, where was x? Negative 1/2, and we have our two answers. And letter C, it's been a long time since I've been able to say this. This one requires just a couple of tweaks. The very first one is that common theme in high-end math. Why don't we bring everything to one side, let it equal 0, and factor it? Now, not much really needs to be said. We swoopy swoop it, and you guys hopefully are good at already recognizing that this one is no solutions. This answer right here would be sine x equals negative 1. And then we get a 270. Now, I just want to speak for one moment about the no solutions. This is now supposed to make a lot more sense. And so over here, this is like a little do not write down zone. Here's the idea. When you are doing the swoops, essentially you're saying sine x plus 6, where is it equal to 0? And then we go sine x equals negative 6. There would be two ways to justify why this is no solutions. Way number one would simply be you could grab your calculator and you could go second function sine in degrees of negative 6, and then your calculator would spit out an error, or it might even light on fire. It doesn't work. But there's even a better way. If we remember the graphs of sine and cosine, and any of you guys moving into calculus, you really should memorize them. Sine, just all by itself, goes up to a height of 1, down to negative 1, and that's one period, and then it keeps repeating itself forward and backward. Well, here's the thing. That is 1. That is negative 1. Sine, all by itself, will never reach a height of negative 6. That's why there's no solutions. Now, on the chapter 4 and 5 evaluation, there was a little bit of a trick question. You guys had a tangent being a value of 9, and many people would be like, oh, it's no solutions. Well, not really. If you remember the graph of tangent does go through every single height. So it does reach a height of 9 and a height of negative 9. That one's a little bit of a trick question, and you needed to use your calculator for it. Now, that's done. Let's move into then the grand finale. The grand finale of then, I really have nothing left to teach you guys about solving trig equations at the high school level, and I have nothing really left to say about the unit circle other than it's a very, very powerful tool. So number 3 is still a solve. And we're going to just change the stipulation. In number 3, we're going to work in radians, which once you understand the unit circle is no big deal. You're just looking up the radian version. However, here is where we get to the highest level. There's, again, nothing left for me to show you guys after this. So this would be what happens. The very first question goes sine 2x minus a cosine x is equal to 0. That's a 2, not a square. That has to be made obvious. Now, the idea is this is nowhere near your happy place. You or us together, have to take this to our happy place. And there's a little bit of work to do. This is where the trig identities come in. So hopefully you've already got out your unit circle and you've got written down all of the identities. Here is how you'd begin. What we have to do is we have to just look at this sine 2x, because I don't know what else you would look at, and we would write down what is its identity. Its identity is 2 sine x cosine x, and then I'm just going to rewrite that cosine x. Again, we are not supposed to know where this is going yet. We're rookies at this. But if I said do something, what else are you going to do? Now here is where some instincts might come in. When you look at now what we have, we could actually do a GCF. The GCF would be cosine x, and we'd be left with 2 sine x minus 1 equals 0. And now we're kind of at that level that chapter 4 was at. We would swoopy swoop. Don't forget that this is a value. This is cosine x equals 0. This is a value as well. This would be 2 sine x minus 1 equals 0. Manipulate it. Bring the 1 over. Divide by 2. These are our two areas that we need to find our values. Then it really is our happy place. We've taken this equation and brought it to two pre-calc 20 level questions. Where is cosine 0? Well, cosine is x over r. In degrees, it'd be 90 and 270, but we're supposed to answer in radians, so pi over 2 and 3 pi over 2, and then same thing. Where is sine x a half? Well, in degrees, it's 30 and 150. Just like the PDF notes, feel free to write that down if it makes you comfortable, but if it says answer in radians, make sure you answer in radians. That is really where today goes. How do we take something to our happy place so we can use the unit circle backwards, and we're going to have to use the trigonometric identities, all of them. So let's go to the second example. And the second example, what we have is we start with cosine squared x equals cotangent x and then sine x. Now here's what I think I'm going to do, because you again have the full PDF notes. I'm going to take this equation and then our last one to our happy place. Once you're at your happy place, you probably don't need me wasting your valuable minutes showing the answers. That's probably the thing that's the easiest for you. The big question is, what would we do? How do we take this to something that's very, very solvable? And again, you're not supposed to just look at this and know right away. That's where the practice comes in. That's why I wasn't able to take away a lot of questions out of the chapter 6 practice. So let's begin. If I looked at this and I just thought, I've got to do something, I've got to start to manipulate it to get to something, probably even a factoring, here is what I would think first of all. Maybe we should manipulate cotangent, and my initial thought before my hand moves, I'd think first, is maybe I could write cotangent as 1 over tan. Imagine 1 over tan, but it doesn't take us anywhere. But then my next thought would be, well, what if we wrote it down as cosine over sine? And that's a good idea, because these signs cancel out. And at least it takes us somewhere. We would have cosine squared is equal to just a simple cosine. Now I know right now you're thinking, well, now what am I going to do? Where does this take me? And no, don't cross something out. You could be losing answers, values of x that would make it work. What we are going to do is do the old bring everything to one side, let it equal 0 and factor it. It just wasn't quite as obvious as up in number 2. Our factoring is yet again a GCF. Sometimes you forget the importance of it. And if you ever doubt it, take it back in and you can confirm that that is the factor. And then we're right back to our happy place. Either this equals 0 or this swoopy swoop equals 0. I'm going to bring the 1 over right away. And now you're into your happy place. Then you can see where these values come from on the unit circle. So again, don't panic. You're not supposed to just look at this and know exactly what to do and then you jump to the answers. It takes a little bit of practice, and sometimes it takes a little bit of trial and error. You might have written down 1 over tan, then you get your eraser out and tweak it. It takes a little bit of time to get to these guys correctly. Now, for our final example, this really is going to highlight the don't panic. You're not supposed to see this right away. Most people wouldn't, but it's not about the first time did you see it. It really is about the second or third. Once you gain a little bit of practice, you no longer really get scared about making some of these calculations. And here's how we're going to begin for this guy. Okay, what we are going to look at is this equation, and we have to somehow again take it to our happy place. Now this is critical, okay, and this will be one of the last times I say it. You have the big sheet of identities with the unit circle. The first 8 identities, called the fundamental 8, I recommended you guys memorize it, and I said you'll never truly be good at chapter 6 or even be comfortable with it until you've memorized them, because you'd keep missing things like this. When you've memorized the first 8 identities, you see this right here. You see that this 1 minus sine squared x, that is something good. What we actually have is 2 cosine x, and then this is again a plus. Sorry, it got kind of messy. 1 minus sine squared x, that is one of the Pythagorean identities. And once you've memorized it, you'd realize, wait a minute, that is equal to cosine squared. That is replaceable. We've done that a few times. And now here's where our final manipulation comes in. We're at a spot where we could bring everything to one side. I'm going to bring everything to the left. I'm going to write it in the order I want. So cosine squared first, then that's a positive 2 cosine x, and then I'm going to minus the 3 over. We have everything to one side. We have it let it equal to 0, and we're going to factor it. And so this guy factors to 2 cosine x minus 1, and then it factors to a cosine x and a plus, sorry you guys, a minus 3. Now, for our solutions, and I really am butchering this one. It's a plus like I originally thought. We're going to get either cosine x minus 1 equals 0, so cosine x equals 1, and that is your happy place, so I won't finish it. Or we're going to have a cosine x equals a negative 3, and that's a no solution again. And lightning quick before we finish, that no solution can be confirmed graphically. If you're going to graph cosine all by itself, this would be 1 period, and then it keeps going forever and ever. 1 and negative 1, it never reaches a height of negative 3. Now, the final thing I want to point out, because this is the second last day of the chapter, is in the PDF notes, just at the end of this section, it says the thought process to solving. And again, you see things like see if anything can be replaced, backup plans, factor. That is for the whole chapter. That's not just for this. That is for simplifying in section 6.1, proving in 6.3. All those ideas are things that, with experience, they will jump out at you.